Welcome back to our learning session. It is for data analyst for social scientists, and it comes under module number 4. Where today we'll talk about auction theory. So let's get started, shall we? Now, what we have is a piece of code here. What it does, can you tell me? This piece of code is for simulation. It is supposed to simulate 1000 times when there are two bidders and bidders can only bid between 0 to 1. It's a random uniform distribution and it creates a matrix and stores that to valuation 1. And we'll print out a valuation 1. Just we'll see what we get, shall we? Let's run this code. When we run this code, what we have is a 1000 number of rows and each row had the values between 0 and 1. Now, this is a way of simulating a valuation for a bidding process when we are trying to sell something. Now we are done with this. Now let's move on to question number 1. Now after doing the simulation above, it is asking is that even though we are simulating random numbers, the use of set seed function allows us to have the same values each time we run this code. Is it true or false? What do you think? Is it true or false? This is true because the job of set seed is to make the code repeatable or verifiable such that reproducible, that's a good word, reproducible such that it can be validated next time we run the code. If you do not set a seed, then what it does is that each time we run a code, we'll get different valuation and we're not able to validate our answer. Now, moving on to question number 2. It says, let us consider a posted price model. In lecture, we saw that expected revenue when there are posted prices is given by PR, VI is greater than P for at least one I, that is for one individual, where P is a posted price, VI is the individual, or I's valuation of the good. Then the expected revenue is equal to this. This is equal to this. Now, the question is asking is that what is the optimal price given this formula and we have a uniform distribution between 0 and 1 for valuation. That's the question here. How do we solve this? Can you tell me? We can solve this by taking this formula, taking the first derivative of this and setting that equal to 0. And then we'll solve for P. And that P will give us the optimal price. So let's get started in R. How to do that implemented in R. For this, we need to load two libraries here. Let's load two libraries here. Then we need to define the function f such that the function is this. This is a function we have, and this is a function we'll assign to f, and then we'll take the first derivative of that. And that's going to be f prime. we'll take the derivative with respect to p and we'll assign that to f prime, and then we evaluate that and assign that to a called function derivative. So let's do that. Function derivative is the function p and evaluate is evaluation of f prime. Now we'll set n equal to 2. N equal to 2, that's the number of bidders. Now what we need to do is we need to we need to take the root of this. That is, actually we need to solve this for p, and it's done by taking the by using uniroot function. It should be like this. We'll take the uniroot function and apply that on the function called function derivative, and the interval will be 0 and 1, and where n is equal to 2. Now what we need to do is we need to print the upload price as the root of this value. That is going to be upload price, and let's print that out too as well. And that is comes out to be 0.577, which is exactly what we need. Now let's summarize what we did today. We talked about auction theory, and we look at the piece of code that is a simulation 1,000 times when there are two bidders, and bidder can only bid between 0 and 1, and it becomes a random uniform distribution, and it gives us like some kind of matrix, what we saw earlier. And we talked about seed and what's the value of seed, why it's important when we run this kind of code. And then in question number 2, we talk about given a formula for expected revenue, can we use that formula to get a price, optimal price when we are putting some item for bidding, and we implement that in R, and it gives a price 0.577. So that's all for today. I will see you next learning session. Thank you so much.